In order to focus public policy in favor of sustainable cities, it is necessary to have information that enables timely monitoring of the growth of cities. But gathering in situ data is often a costly process. Therefore, satellite data is often used as a source of supplemental data for official information. When ground truth information is available, one of its main uses is performing supervised classification. However, limitations are recognized in the traditional pixel-level classification strategy, as it does not consider contextual information of its neighborhood. Hence, a segmentation is often performed before a classification in order to create a set of clusters of pixels to be classified. The use of the Geovia technique is convenient in situations where the pixel size is significantly smaller than the average size of the objects of interest. This occurs in high-resolution images or with technologies such as the Open Data Cube that enable useful country-wide mosaics. In both cases, the objects and phenomena of interest are much larger than the resolution of the pixel. Another process, simpler in its calculation but highly efficient method of pixel aggregation, is the grid-based segmentation, which sacrifices the similarity search strategy by grouping pixels in regular cells. Geovia tries to build meaningful objects that match objects in reality. Each object is presumably different from its environment, meaning size and internal texture will vary. On the other side, grid-based segmentation is a systematic partition that does not consider the underlying characteristics of the pixels and their neighborhood, resulting in an array of regular size cells. While aiming for more efficient or better classifications, Geovia and grid-based segmentation approaches have opposing logics, as the former looks to create visually homogeneous clusters while the latter does not consider any characteristics in the pixel. Regardless of the clustering method used, it is possible to perform statistical analysis of the resulting image patches in order to characterize them. For example, it is possible to quantify its texture by analyzing the spectral values or identifying spatial patterns. There are multiple techniques to carry out such characterization. Our study offers a comparative assessment of these two different segmentation methods used in Landsat countrywide image composites prior to classifying urban settlements, using pre-existing official information as ground truth, at two different points in time, year 2010 and 2020. For the parallel feature extraction stages, we selected 5 statistical summaries of the resulting patches of each segmentation method. To compare the performance of both segmentation methods, we ran 6 different classification algorithms. The algorithms were tested using the training and testing datasets created for each reference year. When comparing the different classifiers through their macro F1 score, grid-based classification showed the best result. Grid 1. This outcome is unexpected because of the theoretical advantages of image patches created of pixels grouped by similarities. A grid-based approach also shows strong advantages when it comes to computational and time costs. Furthermore, the modifiable aerial unit problem is also in check when using a grid, plus the comparability in time is easier when the area unit used is fixed. The results open new questions related to the convenience to use object-based image analysis as an image segmentation method in remote sensing problems. This research is relevant for information producers as well as national statistical offices that can benefit from rigorous methods to derive socio-demographic information from satellite data and that wish to select a segmentation method based on its likely performance and costs.